There you go. Can you see my camera?
Yes. Let me just. Hi everyone, thanks for joining today's session, Containers on Azure. Today we have a special guest, George, who is a senior cloud advocate at Microsoft, and he'll be taking us through the Azure containers and how you can get started, how you can learn it, and how you can advance in that. So yeah, without any more delay, let's get into it. Over to you.
Hey, thanks, Rod. Thanks for inviting me. I hope everyone can see my camera there now. My share. Yeah, I'm a cloud developer advocate for Microsoft. I'm based here in Melbourne, and I work with the cloud native in container space. And that's why I propose us to discuss about the containers on Azure, because there is a lot of interesting that we can discuss. What are we doing on containers on Azure these days? And let's see how I can go through that. If you go for this QR code, you can see my profile, you can see my contacts, and please feel free to to reach out. And even if you work with customers or if you want to learn something, I like to work with the community and help people to to learn and grow as well. Um, Slide disappeared. There you go. If you don't know me, I have this Azure community called Azure tar. It's like a tarball, a zip file for Azure, where there are a lot of videos, there are blogs as well, Twitter, LinkedIn account. I really appreciate if you take your moment now, go on youtube.com Azure tar, as you can see the link here, and you subscribe to the channel. I really appreciate your support, and I think it can grow the channel. It's almost 2,000 people there already. And also subscribe for this community that you're part of if you haven't yet. I'm sure Shurag will be very happy for people subscribing to the channel. You can probably share on the chat, Shurag. But the Azure is a community where we have videos in multiple languages. If you want to do in your language as well, let me know. I'll have more videos in English, but also in Portuguese. Now let's go for the containers on Azure. What's containers? And I'm trying to find something. Let me see the just get the chat here. Just a second. I want to see the. If you guys can put on the chat, I'm going to open here another screen. On the set screen, what kind of experience you have on containers itself? Someone said voice is not clear. Is that correct?
I don't think so. It's clear to me at least.
Is clear to you? Is all good?
Yes.
Okay. And what I don't know is we have, I don't know how many people we have here. We have a lot of people here. And then what's your experience with containers? Like more than 100 people. What you have done to containers? Are you beginners? Are you like, have have you run like Docker containers before? You know what Docker container is? Can you write on the chat there? Let us know. Write on the chat. I'm learning containers. I'm working with containers. I run containers in production. Beginner. Okay, a couple of beginners. Anyone running production? Beginner, beginner. Anyone running that or working with containers? Refreshing. Someone refreshing the idea. Beginner. Okay. Someone watching videos. Okay. Beginner. Okay, looks like the majority is beginner. If there is anyone with experience, let me know. I can give you more advanced at the end. But I was expecting more beginners as well. Yep, that's nice. That's beginners. And let's try to understand what do you do to start, understand what container is and how you can use Azure, the Azure public cloud, to work with containers. Okay, you need the base. Majority is asking for like a basic container knowledge to understand what containers are. At least I have more than 10 people saying from 100, like it's more. That's good. That's good. You are on the right place. That's what we're trying to bring here. And the first thing for us to understand containers is your local development environment. You can do that multiple ways. Another beginner, mostly beginners. Then what's that local development environment for you to understand containers? Now, right now, if you have any of those environments installed in your machine or you play with anyone, could be Docker desktop, Rancher desktop, could be K3s, K3d kind, or just a Docker directly on Linux or Windows or Mac. I have a Windows machine here, and I use something I call Windows Subsystem for Linux. Anyone have used Windows Subsystem for Linux on Windows? On Windows, you can install Windows Subsystem for Linux. Then you have what we call Linux inside Windows. Now I'm going to be using that, and I'll be installing. I have Docker Desktop running on my machine, on my Windows 11 machine, where I'm running Docker, I'm running Kubernetes. That's the Kubernetes icon here, and you have kind. Kind of is a kind of a way to, you see Kubernetes inside like a bottle. It's because we are creating a cluster. We're going to understand what's a Kubernetes cluster using Docker. And those are the things when you learn in containers. Is Docker, is like Containerd, is Kubernetes, all the public clouds like Azure, having those offers to run containers and run Kubernetes clusters on the public cloud. Then what's a container, George? I'm a developer. Who's a developer here? Developers first or admin? Just right there. Developer or sysadmin or DevOps? If you can write down the chat to let me know what you are. If you are looking to be a developer, sysadmin, or if you are already, or if you are studying, but DevOps, devs. Okay, nice. My background is development. There's another developer there. There's a lot of devs there. Someone haven't decided yet. Developer, DevOps, developer. Nice. Nice. Undecided, I love it. Exactly. You don't have to decide, to be honest. If you are at university or learning, sysadmin. Many years ago, I used to say sysadmin, someone was managing like on-premise data centers. And now DevOps more cloud related, and DevOps also, you can write code. You can do both. IT support, aspiring dev. Okay, there's a lot of mix here. But if you are a developer sysadmin, what's a Docker container? Like, if you understand what the operating system is, like Windows, Linux, there's a kernel. The kernel is like in Linux, like you have here on my screen. Linux kernel is like, the kernel is the one that manages the hardware, manage the device, storage, disk, CPU, memory, everything. Is the way that, like a bash shell or PowerShell that communicates with the hardware and manage pretty much everything of the machine. As we call Linux kernel, Windows kernel. And the way that you run things on Windows and Linux is we call process. You create a process to run your application. Then when you write a code in Python, in .NET, in Go, in Rust, any language, you create a like executable and something that you're going to execute and going to run on a machine, and that runs on top like a process on top of the kernel. Then the kernel is going to allocate memory, CPU, and you're going to run that process there. And what happened with a container is that we want to run multiple applications on the same machine, but isolated from each other. That's what container came from. Came from isolation of workloads. Workloads is your application. You wrote something you want to isolate. And then many years ago, we created something virtual machine. Virtual machine was a hardware isolation. Then we need to understand the hardware to isolate, not just on the software layer, on the kernel layer. We isolate also on the physical machine. Then, when a new generation of virtualization came for Intel and other chips, you could do virtualization on the hardware. But containers said, no, let's also create virtualization on the kernel level. And that's what Docker started, a company called Docker. They only saw this feature on the Linux kernel. Some of the features on the Linux kernel. See groups and namespace. Those are features on the Linux kernel that was available for many, many years. I don't know, maybe 15, 20 years, a long time. And then Docker was a company that said, let's simplify that. Let's use that and make this available as a command line interface, a CLI, to everyone. Then Docker creates something called Docker D, Docker Container D, and Run C. Those are libraries to run containers. Then a Linux container, nothing more than is getting your code and running with this Run C. That's like a software that was created by Docker at the time. And all these things became open source. People know something called Moby. Moby is the open source side of Docker. Container D is part of the CNCF that you're going to see here. And then Docker created this, run C library that you could create a deploy application inside like a namespace, complete isolated from each other. Then now you could get the same machine and run like 5 or 10 application for customers. That's what Docker started. Docker used to sell website and hosting for companies. And they get your web application, they run isolated on the same machine, and they could sell that isolation for customers. And they not be competing for resource, like for CPU and memory. They'll be completely safely isolated from each other. And that's what the Docker is. And Containerd was like a library because runc was too complicated, and Containerd came as a library to simplify this. Okay, and still very complex, but simplifies that. And then Windows come. 2015, Microsoft starting. I worked for Microsoft and I followed that when I was Microsoft MVP. I worked for Microsoft for 4 years, but before I was Microsoft MVP, what's called Most Valuable Professional. That, by the way, anyone here can become an MVP and get a lot of benefits. You get $10,000 credits per year. You get option to go to Redmond to visit Microsoft every year as well. There's a lot of benefits to become Microsoft MVP. It's someone that's helping the community, for free and helping learning, helping the community. You can become what we call most valuable profession. Anyone interested to become an MVP there? Microsoft most valuable professional, let me know. See, I can see hands up there. It's nice. I was MVP for 3 years before I joined Microsoft. And when I was MVP, I was doing private preview for these. And because of this, I was invited to present at Microsoft Ignite in end of 2015 to talk about this. And I talked about this in November 2015, where nobody knew about Docker at the time. And I was presenting in Gold Coast here in Australia about this in a big event with a lot of people there. And what's that? What Microsoft created? By the way, Windows containers, that's how we call now, is growing very fast on Azure at the moment. And we did the same thing. We did the Windows kernel like you see here, and we create the same thing that you saw before for Linux, we have now for Windows. But we did something more. Some customers asked for, we also need a second level of isolation that we call Hyper-V isolation, okay? And on the right, you can see Hyper-V containers here. Then now on Windows, we have 2 different ways. We can do a normal like kernel container, and we create the same features that have on Linux kernel on Windows. And you can run also inside the virtual machine. And if you don't know, on Windows, the virtualization framework that we use or software that we use to create virtual machines on Windows is called Hyper-V. Is hyper-virtualization. That's the name of the product that creates virtual machines on Windows. And now we have both. We have Windows and Linux containers. And that's another thing that Microsoft created was running Linux containers inside Windows. And that's pretty much what I'm using on what I call Windows Subsystem for Linux, is using the same technology where I'm able to run on Windows, Windows and Linux kernels now. What they use something called utility VM. That's a lightweight virtualization to run a different operating system inside Windows. I'm not going into details because that's a little bit more, advanced thing, but the first thing that you have to understand if you're a developer to work with containers is how you create something called container package, or the name is container image. Container image is like, okay, I have an application that I want to deploy. I want to package this application to deploy. That's my package. Many years ago, we used to say MSI to install application on Windows. Now, if you want to install like a container somewhere, you need a Docker image or container image. A lot of people know as a Docker image, nothing more than getting all the dependencies of your application and saving these in a format that we call container image. And like in Linux and now on Windows as well, to install applications, nothing more than copying files. You copy all the files and you need all the packages for Linux for the operating system to run your application. All the dependency that you have to install on Linux, let's say, before you run your application. The same on Windows, the same on other operating system. But let's focus on Linux now, okay? And then what Microsoft did, Microsoft created like, let's say for .NET, they create the base image. They create like all the dependencies that you need to run, let's say, .NET. And you have the same for all the languages. You have container base container image with all the dependencies, like runtime dependencies to run your application. Microsoft did the same, and I'll be looking the questions here soon. And if you have any questions, just write these down, and we can stop in some stage and go for the questions. But let's say if you want to run .NET, if you want to run .NET image or create a .NET image to run your .NET application, any .NET developer there, put hands up. Which language you guys using? Which programming language? Yeah, write down there. If you're using Python, which language you want to learn, or you will learn already. Write down there on the chat. It'll be nice to understand what language you are working at the moment. Python, Java, still Java, C#, Python, PHP. Well, it's a .NET, Python, nice, Java. We have a mix here, Python, Java, .NET, PHP as well. Wow, C++. Yeah, PHP, C++ are very old language, Java as well. I remember I learned PHP in 2000, like 23 years ago. And it's crazy how, time flies. And C#, PHP, Python. Python is growing very fast, but it's a very nice language to learn these days, and Rust as well. Oh, we even assembly, HTML, nice. Then if you want to do .NET, you want to package your application. And the Docker file, you can do that. Now in .NET 7 or 8, you're going to be able to create this Docker image even without the Docker file. The .NET SDK now allows us to create the Docker image without the Docker file. But the majority of the language is still using Docker file, then I recommend you stick with Dockerfile for a while. Then Dockerfile have what you call stage. The first stage is we create what you call a base image. That's in my example. You can do the way that you want. And you can see the purple image here is just the ESP.NET that I need to run my application. And I'm going to expose port 80, port 443. Then now we keep this base image. That's where you're going to run our application. And now I need to build my application. Inside Dockerfile, when you're going to run a command to build this Docker file that you're writing here, it's called Docker build. You can have multiple stages. Each from is a new stage. We're going to create the second stage to build the application. Then we copy the code. We run the .NET restore the package for the project. Then we copy that and you run .NET build. Once we have this, we need another layer to publish, another from. Now we're going to copy from build, see from build, from the step, the previous step, we're going to publish this. We're going to run .NET publish. And the final from, I'm going to copy from the base. That will be my runtime image. Everything before this, all the build and publish is going to disappear. I'm just copying from the publish and setting like an entry point, the DLL that I need to run. And that's my final image. And everything else disappears. That's your final Docker image, the Docker file. But the end result will be like a container image with your code built and published. And the only dependence will be the ASP.NET Core base. It will be very lightweight because you don't need SDK, you don't need anything. And that's the container image that we save. And what do we do with this container image? We save these with something called container registry. Like GitHub, where you save your code, you push your code. Container registry is a place where you push your template, your container image, your Docker image. You push your kind of deployment package where you're going to run this container. And if you see this diagram, number one, you have Docker file. You can run Docker build to build this container image. You save that in a container registry, and then from your environment, from Docker, from like a Kubernetes cluster, you can run now those applications. But you need the container image before you run that. Okay, and there are things that I'm not going into much details here that you can use, like Helm package is a way to create the deployment file, because you're going to understand that Kubernetes, they talk YAML file. There are some YAML files, like specs that you have to write down to deploy applications on Kubernetes. But at the end of the day, Kubernetes is just getting your container registry, and they're going to run inside a Kubernetes cluster. And your application running inside the Kubernetes cluster, Kubernetes call a pod. Okay, a pod could be multiple containers, and Kubernetes call containers a pod. It's not the same thing, but that's normally how people call. And Docker call like a container. And most of the applications that you see on Azure is running on top of Kubernetes. It's not many things running on Docker anymore, but mostly using Kubernetes. Kubernetes used to have a strong dependency on Docker, but not anymore. And the only dependency now they have is on the open source projects. And that's how it works now. Kubernetes these days, it's a little bit complex. I'm not going into details, but for you to understand, you have a physical machine. You have your physical machine. Kubernetes, when they install on that machine, they install something called kubelet. And that kubelet that can control that machine for Kubernetes. And Kubernetes just use that library that we talked before, Containerd. That's a high-level library that was initially created by Docker and was donated for a foundation that maintains this code now. And then Containerd goes and run the container. But like I said, there's a library in between container D and the container. It's called runc for Linux. And then if you go more in details, that's how it works. Okay, there is like a connection with networking called CNI, Container Network Interface. That's how a container can have like IP, the same as like a machine, have IP number for the network. And that's how Kubernetes and Docker works, very, deep level. I'm showing that because if you wanted to understand how this works, you have to go, deeper and deeper to understand how those things work. And if you are just starting, you don't have to understand all those details. But I always like to explain the hard way, then you're going to see the easy way. And where is this come from? All this complexity and things just to run my application. I just want to run my application. And before I go forward, I'm just going to show the Docker desktop that I was talking about. That's my local development. I hope everyone can see that. Then I have installed here what we call Docker desktop, okay? The same for if you go on my, close here to my Windows, you can see that Docker is running. There's an icon here for Docker. Docker is running in background, and that's the application, and that's showing what's running on my machine. When you install Docker desktop in your machine, everything's running locally, okay? And then I have a lot of things running here, and you can see the Docker image that I have. And there is one thing called Docker Hub. It's like a container registry that Docker maintains, like public. You can use mostly for free. And also you can see volumes like disk that you can attach to your application. You want to run your application in isolation, but you also want to have storage. You want to save disk or have storage, and you can attach volumes. That's what we call Docker, Docker desktop. And when you install Docker desktop, this is running. I have here my Windows terminal. It's like command line on Windows. Let's show you. Is the font big enough? If you type Docker, because I have Docker installed, you can see all the commands that Docker can allow us to do. One of them is Docker PS, where you're going to run all the containers that are running. And the funny thing here, from Docker, I can see the containers running on Azure. Docker has an integration with Azure Container Instance. And Azure Container Instance is the first product that I want to talk about on Azure, because the talk is about containers on Azure. The first product that we created was Azure Container Instance. That's nothing more than get a single container application, and you will run on Azure. And you can even have a IP number. You can, have your domain, and you can run these. Or you can run background applications that run like overnight. It's very good for a lot of use cases, not for all. And that's called Azure Container Instance. Let me go for my Azure portal here. Always on that Azure portal here. And then I go for container instance. And that container instance that I created here is exactly the one that I'm showing here on the terminal. This, see the name, is the same name. I was able to run a Docker command and create this container from here. How I did it? Let me show you that. I have let me run a little bit bigger the font. I just run this command there. Docker run expose import 80. running this container image. That's how Docker run works. But before I do that, I just set the context to use ACI context. That's to deploy this on Azure and not locally. Okay, you can do that with other clouds as well. I'm showing you on Azure. And then when I run that command with this context, I running that on Azure. Then that's exactly what happened there. And then if I get this IP number, I think I have this running there. I have Nginx, that's like a web HTTP reverse proxy where I can deploy my web application. There is nothing running here, but you could be deploying your application here. Okay, that's very, very simple to do it. Can I do another one to prove? Let's create this one. That one is very light. I can do the same. Let me just prove here that I'm using Docker context LS. As you can see, I have ACI context that's pointing to Azure. And I also have my default that's using Moby locally to run locally. And if I start, that means that I'm using this context. And what I have to do is just run this command, Docker run. And normally when you do Docker run locally, you can see the container running here. But in this case, I'm not running locally. And then I have to go back to the Azure portal and do a refresh here and wait for that to be created. Let's go refresh. Any questions so far? Yeah, please, there's a YouTube channel there. If you can subscribe to the Azure Task channel, I really appreciate. And follow the community, follow the blogs. And if you want to record with us, you don't have to be a full expert to record videos. You can, Azure Task is exactly to help the community to create content. I'm going to help you, someone like a mentor from Azure Task is going to help you to create your content. And you can learn how to create content, how to create blogs, how to create videos. And there you go, you can see serverless days, the one that I just created from the command line. Not from here, sorry, from the Visual Studio Code. I'm using Visual Studio Code, by the way, if you want to use, I recommend, and it was created from here. And that's the container. If I copy again, I should have Nginx, another instance of Nginx. Takes some seconds to start the application here. But that's a container image. I have this container, as you can see, container, you can see the containers here. And by the way, on Azure Container Instance, you can run more than one container. You can have multiple containers running together, sharing the same namespace. Remember, I was talking about isolation. On Kubernetes, you can have multiple containers running on the same isolation. In case you wanna, break your microservice or break your application in components, you can run in multiple containers, but all running on the same namespace. That's what a container instance is a namespace where you run one or multiple containers for you. Why you wanna separate your application? Maybe you wanna run, like something that runs just like once a day in background, or maybe you want to run authentication in a separate component, but running all together on the same namespace, but different processing. It's like I have a virtual machine and running multiple things inside that virtual machine. You could simulate a virtual machine with a container group. You can run multiple processes like separate, but on the same group, on the same isolation. In this example, I'm just running one. And then I have Nginx now running. That's the deployment I just did it. That's the container instance. And here you can even have logs. You can connect on the container running there. From here, you can have bash or the two cup of bash that you can have, the shells. The shell is the command line that you can use, sh or bash. Press enter to reconnect. We don't have bash on this Alpine version of Nginx, means that you have to add sh. And if I try to use sh, there you go. I'm inside the container. That's like a Linux container where yeah, I have my application running in there. And that's just like a Linux. If I do like a top, you can see Nginx worker process running there and nothing more. It's just my bash, my sh process running here. The top, that's exactly this application that show everything. And I think they're using just tail to get the logs. That's it. That's the container running. And I'm inside the container here from the Azure portal. But I create this container from the Docker command line. That's an easy way to start. I start showing, from the local desktop to the Azure, but let me show locally, completely locally now. And that's the Azure Container Instance. It's very simple. It's very useful for a lot of use cases, like background jobs, even a web application API, anything. And you only pay when it's running. If you stop there, if I go here and I don't have to really, remove, I can just stop. If I stop, I don't pay for that. Okay. Then that's pretty much, if there's one, I think this one's not running, you say like, is it stopping? And I'm not paying for that. Then I have all these three running now. If I go back on my command line, if I go docker ps to see the containers running, that's the command for Docker. Now I can see two, the one that I created before and the new one. Nice. George, I wanna move away from running on Azure. I wanna run locally. Then you go in set context Docker. Right. Docker. Here, context use default. There you go. Now I'm back to the local Docker. That's how where you split from local context to ACI context. Now that's my local Docker. And if I go again and say ACI context and do Docker PS, I'm now pointing to the Azure containers. It's kind of a separation of what's a local environment, what's Azure or another clouds using Docker context. Okay. Then I'll be using the local default now. And I'm sure that you can run exactly the same here, but running on my local. Then I'm going to use port, my local port 8080, because now I'm running locally. I want to expose a port on my computer. Then because port 80 I'm using for another something else, I'm going to use a different port number. I'm going to use 8080, and I'm going to point all the traffic that I call for port 8080 to port 80 inside the container. Because the container is running on port 80, expecting people calling on the port 80. That's normal HTTP port. But because I'm running locally, I want to use different ports. We don't have a Docker, the container image, you're unable to find. Docker is going to download from the cloud the container image and then going to run the container. Wait a second. Another nice way to use, if you don't like command line, is to use the Docker extension of Visual Studio Code, where you can also see all the containers running there. You can see the registries and the image. And one nice thing is, let's refresh. That's the Nginx. That's the container that I just did run. That's just because they kind of inside the container here waiting for workloads. And the same you can see on the Docker desktop. And let me see, the one that I just created was this Alpine there. And then you can click on this button, 88, and there you go. Localhost port 8080, that's my application running locally. Okay. Like I said, multiple ways from Docker desktop. You can see from the Docker extension on VS Code, or you can even see locally. A nice thing is because I did run Docker desktop and I put I haven't set to run. If you want to run complete detached from your your bash, your shell, you have to put a -d here as well. Because I haven't done that, I can see all the logs coming. How can I prove that? Let me call the web browser multiple times, refresh here multiple times, and go back to the logs. And there you can see all the logs inside the container. If you want to leave the container, you do control, you hold the key control, and you click P and key and Q. I'll have to go here and say P and Q. I don't think I can, but anyway. Yeah, then I left the container now. I put on the chat here. If you want to leave the container, I think is Control plus P plus Q. Okay. Now I have, if I Docker PS, like I said, the container is not running because I just stopped the container. Then I should be stopped here as well. But I can go back and manually start again. If I start again, the container is running. No big deal. That's container in a nutshell. Okay. Any question right there? If you understand what a container is, you need a container image. You need to run that, and to start, it's nice using Docker Desktop. You can run your containers locally. You can use Docker Context to run that on Azure Container Instance, and that's the first way that you learn, how to use containers. Just build your code. You can run the Docker build commands locally here as well, that I was talking about. And if you go Docker build, you're going to see the documentation --help, how you can build your container image. Okay, let's go back here. Where Kubernetes came in place, and for me to be able to talk about Kubernetes as a more complex thing, I have to explain where this comes from. Kubernetes now is part of this foundation. It's called Cloud Native Compute Foundation, where all what we call the cloud native products or projects, open source projects, are part of. There are a lot of them, and that's the definition of cloud native: to build and scale applications in a modern, dynamic environment in public, private, hybrid clouds. Could be on premise, on the data center, on the public cloud like Azure, or in hybrid, in both, or even on the edge. Your Raspberry Pi that you have there, the ARM things, they can run that. And normally cloud native is associated with containers, because containers is probably the easy way to do all these other things to scale, because they are very fast to create. Different from like a virtual machine that's very heavy. Containers are lightweight. And containers are immutable, means that they don't change. You don't patch a container. If you change something in your application, version 2, you're going to rebuild, create a new container image, and you're going to redeploy. But because it's very fast to run the container, it'll be like milliseconds. containers is very appropriated to use, to work with Cloud Native. Then cncf.io is where you can find those projects, and Kubernetes is the main one. You can see Kubernetes here. And there are three, groups of projects. One is graduated. Those are the main ones. Incubating also, because they are, in some stage be graduated. And Kubernetes is the main one. Everything, I think, runs around Kubernetes here. But there are projects that they run without Kubernetes, so this is not like a mandatory thing with Kubernetes. And I say Containerd, that's the high-level library that I was talking about. It's part of Containerd. And you as a developer, if you want to, have your name on the market, as a nice way to do is to help those projects. You can become a maintainer, not a maintainer, but a contributor first, and maybe some stage became a maintainer. Is anyone helping any CNCF project here? Someone asking about the feedback form. Yeah, I'm not sure. And then, but if you guys have any questions about containers, please put on the chat. And those CNCFs are the projects where you, as a developer, you're learning, how to code. You can quickly start helping those projects with small things and keep learning, helping those projects. Helping those projects is a good way to learn, because when you are, at university, you learn, you are on the first 3 years of your career, you still you're learning a lot. And sometimes you don't have like a real nice project to write code. And those projects are a nice way to, to spend sometimes something very important for the community and also for you to learn. And I recommend any of those projects. There are some videos on the Azure TA where I'm talking with some people from those projects, and they also explain how you can help, can be part of those projects. They normally have like weekly or fortnightly meetings where you can follow the recordings or can follow live, and you can see how you can help. I think there's someone putting hands up there. You can write down the question if you want. And those are the projects. There are projects called on Sandbox. There are like new projects coming. It's called Sandbox projects. Mostly are new ideas, and doesn't mean that going forward, but there's a big chance that if the community likes a project, that this project going to become like an incubated project, in some stage will be graduated. Okay, that's CNCF. And where Cloud Native is on Azure. Now bringing containers to Azure, we have a few products. One of the main products called Azure Kubernetes Service here in the middle. We also have Kubernetes done by Red Hat called OpenShift. We have a serverless version of Kubernetes called Azure Container Apps. The difference between Azure Container Apps and Azure Kubernetes Services, one is very like kind of a serverless offer where you don't have to manage many things, but it's not as flexible as Azure Kubernetes Service. I recommend you start with Azure Container Apps or Azure Container Instance, like I was showing before, or even Azure Function if you want to go for serverless. But even Azure Function, we are using containers to run, Azure Functions, and means that the containers and Kubernetes are the foundation of all the clouds now. Even if using some of those products that you can see here from Azure for security, for AI, for database, most of those products are running on top of Kubernetes, on top of some virtualization, some kind of container technology. Okay. Can you use Azure for free? There's some question here. Can you use Azure for free to practice that? Yeah, you can create a subscription on Azure for free. And you can run Azure Container Instance like I was doing from Docker. Yes, you can. There are some credit there that you can use. Also look for the student credits that you have, that you want. I think students can also use GitHub and GitHub Copilot, all these new technology. That's a question. Yes, you can. Sandbox. If you don't have a computer, you can try to use some sandbox environments, that will be public, like code space. GitHub code space is a way that you have a kind of a Linux machine and comes with Docker. I'm not sure if GitHub, you can see if GitHub if they have code space for students as well. GitHub code space is a good way. Let me write down there, or someone can put a link for GitHub code space, please. GitHub code space, you connect kind of like a virtual machine where you can run Visual Studio Code, you can run Docker, you can even run Kubernetes there as well. Another question here is how to define port mapping with remote container application, use Docker Compose, go to AKS. Yeah, then normally only the front end will be exposing the port, and the other one is not. I think I have something here that if I have time, I can try to show later. That's a good question. How easy is to go to AKS after getting on Azure Container Apps? You're going to see that? You're going to see that? Keep the questions. Then I'm going to keep some questions for later, okay? But the difference is, I recommend you start with Docker, container instance, then container apps, then Kubernetes. Doesn't mean that you have to move. You can use both. Depends of your workload. Some applications they can run on container instance, some things on Azure Functions, some things container apps, some things on Kubernetes. Okay, depends of how you're going to do it. And Azure now has this thing called Azure Arc here at the bottom. It's kind of a way that now we can, from Azure, you can manage things running on Azure, running on other clouds, and even running on your data center, physical machines, like we go on-premise physical machines on your data center. It's called Azure Arc. I'm not going details today on Azure Arc, but I recommend you guys to have a look later on Azure Arc as well. Let's go one way up. And what's Azure Kubernetes Service? Okay, let's understand the more complex way. Then you go for the simplest way later. Kubernetes, now you can run any type of workloads. That's what we call on Azure Kubernetes Service, we call node pools. You can have pools for Linux, Windows, ARM64, that's like Raspberry Pi. You can have for GPUs, you can have for isolation, like Hyper-V isolation. You can even have for confidential computing. That's a new technology done by the chip vendors, where you can isolate even the memory and the things that run inside the chip, inside the hardware, not just on the operating system level, on the kernel level. It's called confidential. It's very important for enterprise, banking, government customers using confidential. That's the top. Confidential is the top. Isolated is also on the top of enterprise and safe and secure. These ones. And if you never heard about WASM, WASM is what called WebAssembly technology. Also, you can run inside the Azure Kubernetes Service. And George, there is an integration. Why you put ACI there? ACI means that's something we call virtual nodes on AKS or virtual kubelet. It's also part of CNCF. Is a project that let you, the same way that Docker integrated Docker desktop with Azure, we integrated Azure Kubernetes or Kubernetes with Azure Container Instance. Means that I can ask Kubernetes to run something, but that application is not going to run on Kubernetes. It's going to run the same way that I was showing before on Azure Container Instance. That's a nice way to run background applications, things that run just one group of containers and nothing more, and run for some period and it stops. Virtual kubelet or virtual nodes on AKS is very nice for that. But look this, why we need Kubernetes on Azure? Why you cannot run Kubernetes locally? Kubernetes itself is a very complex, beast. It's very complex. And all these blue box here that control plane, Azure manage that for you. You don't pay for that. You can pay in production if you want to have like a, agreement or service levels agreement. But for development, for testing, you don't pay for that. It's free. And you only pay for those, workloads that you're creating. You don't have to create all of them. You can pick one, let's say Linux, and you can run. You don't have to have like 8 VMs like I have here. You can have just one VM, and you can ask AKS to scale up and down. Scale those machines. Scale means if you need more memory and CPU to run your application, they're going to create another machine. And when you say a Kubernetes cluster, that's why it's a cluster. A cluster is a group of machines that Kubernetes looked for this group of machines as a single one. Because we cannot have a machine with 100 or 2,000 CPUs and 2,000 gigabytes of memory. The way that you create a cluster is getting multiple VMs and manage it then as a single thing. And a cluster is Kubernetes looks for those VMs like 4 cores and 16 gig of memory, and they look as a big machine. And what Kubernetes does, that's why we call Kubernetes an orchestrator, because Kubernetes is just looking for this bunch of VMs there that we don't care, we don't manage. They manage that for us. They update, do the whole thing. But they look at this as a big machine, and they look where there are CPU and memory available for them to run your application. Then imagine that you have just this Linux pool group of machines here. You haven't, you're only using Linux. You don't need all the others. That's fine. Then your AKS cluster will be just this Linux group here. Then you want to run like 5 applications there. But you don't care where the application is going to be running. You're only going to ask Kubernetes, can you run this application for me? And if Kubernetes cannot find space on the first VM, you see that first VM here, they're going to create the second one. There is no 8 VMs here. I'm just supposing. I'm just guessing like a cluster with 8 VMs. But because you're using auto scaling, means that up and down all the time. Let's say that you have just VM number 1, and you have just one application running, but you want to run 5 applications. Then that VM is not going to be enough to run all 5. Then they're going to create the second, the third one, and they're going to spread your application across all 3 VMs, and you don't have to care about that. They're going to do all this magic for you. And that looks simple, but trust me, a few years ago, it used to be a nightmare. And because they can scale this down when they are not running anything, or you ask to stop your application, we can stop paying for those VMs when they stop as well. That's the magic of Kubernetes. And even better, if one of those VMs have like 3 VMs running on this Linux pool, and one of these 3 VMs fails, crash, they're going to boot another VM, and they're going to move all your applications to the next one, and you don't have to do anything. Okay, they fix the application, they fix the infrastructure to run your application themselves. And that's how the clouds provide service for you, how Azure provides service and how the other clouds provide service. They're using, in many projects using these. Okay. That's the virtual kubelet where we run things outside the cluster. I'm not going details, but that's how Kubernetes works. We have this control plane where we don't manage. But on this control plane, Microsoft on AKS give you like a API. Okay, an API that your command line is going to call to deploy application. And every time that this API server on Azure Kubernetes Server receive your what we call manifest using a YAML file, you call this API and say, can you deploy this application for me? Inside this manifest, this YAML file will be your container image, And I'm going to show YAML file here. And then the API server is going to say, okay, I have to look the VMs on the cluster. See, nodes are the VMs, virtual machines. And they talk with this thing called kubelet on the VMs and ask for CPU and memory available for each one of them. And if there is space, they're going to schedule your application to run, and the container runtime, that's run C that you saw before, is going to run your application. That's all done by the cluster. That's the magic. When people ask you now how Kubernetes runs something, that's how they do it. We call our API, the API do a schedule something, talk with the physical machines on the cluster. They know how much memory and CPU are available, and they're going to find a space to run your application, where you have to tell them how much CPU and memory you need to run your application. I need 1 core, and I need 2 gig of memory, 1 gig of memory, or 500 megabytes. Doesn't matter. You're going to tell them how much you need it. They're going to find a space to run your application. And that's basically how Kubernetes works. Another thing Kubernetes does, this kubeproxy there, they talk with the virtual network on Azure. Azure has something called virtual network, where you create like a network of machines, of containers. Container now could be like a machine on the network. And they get like IP number for your containers. They can attach disk or Azure files to your application running there. Imagine that your ESP.NET application or Python application that you want to connect with Azure files on Azure, or have like an Azure disk running there. You can do that with containers as well, the same way they do with virtual machines. Okay, that's pretty much how Kubernetes cluster works. And any question on that before I go? I think someone asked, what's the difference for container apps and these? Container apps is you're going to talk with the same, you don't talk directly with the Kubernetes API, this API here. On container apps, you talk with the Azure API and ask to deploy something. But behind the scene is like AKS running, because Azure Container Apps runs on top of AKS. You cannot see it, but it's running there. Okay, and then I can stop and go for my browser, and maybe I can show Container Apps in a Kubernetes class. Then because they're both using Kubernetes, you're going to understand what I'm saying. Then I think I can go Container Apps. Container Apps. I have a few of them running here. Let's get to one. I'll show this one. Let's see. When I create a container app, and that's the, let's see what's running here. I think there's like a test. And look at this. Why it's taking a while to run? Because I'm pretty sure that's not running. It's scaling to 0. Let's get here. Scale in replicas. I set the scale that to 0, means that, yep, now that's running. And if I come here, refresh, I should be replicas. Now I have one replica running. Why it took a while? Because I set mine to scale to 0, means that if nobody's calling my application, the application is going to scale to 0, and I'm going to pay. And you say, George, but if someone calls my application, I want this to be available. But that's the beauty of containers, because they can start a container very quickly. You can just scale to 0, and like I did here, took maybe a few seconds, but then the application is running now. And that's what they call container apps. That's one of the biggest difference for container apps and AKS, someone I was asking, is that it's very easy for container apps to scale to 0 and you don't pay. But even you say, Joe, I don't want the customer waiting seconds. They're not going to wait just the first one. Look, now if I run again, I can give you the link. I'm going to put the link here on the post. Let's do some traffic here. Doesn't matter. Call this link. See if you can run my application from that. If everyone calls, not sure if that's going to scale more, but I'm asking them to outscale. Let's say it's back to 0 and was created 4/7. That's my time. Was on demand. Why is this nice? Because you don't pay. If your application is just something that you play that maybe someone's going to access, once a day or something, or you can use container apps and you don't pay. Let's scale to 0 and only pay when someone access. And then after, I think maximum 5 minutes, they're going to scale to down to 0 and you don't pay. What do you think about that? It's amazing because the main problem is you can run serverless. Yes, you can. You can do Azure Functions, and you only pay for the consumption as well. But if you want to have at least one instance of application running, and you only pay for when people call, Container Apps is probably the best option. Because the way that they charge is they only charge a small fee when there is no one calling your application. Understand that? It's called idle fee. If you look on the documentation, it's called idle fee. It's only even if you set one instance to always be running, but nobody's calling the application, you only pay this small fee. It's like, I don't know, 20, 30% of the full value. If you try to do the same on Azure Functions, it'll be more expensive probably than this one here. Understand? There's one question here. Okay, someone leaving, but I think someone asked the difference between container apps and thing. I'm not sure if you guys call what I saw, but let me try to see the monitoring side. There you go. Network outbound. You can see all the metrics of the applications from here. Memory, CPU. You can also set, your domain for your application. You can have secrets that are going to be used by your application. You can use authentication. Means that Azure Container Apps now have everything that you can pretty much do on Azure App Service, or you can do on Kubernetes Service, but now having a fully managed and serverless way. The way that you scale your application now, you can use multiple. If I deployed, if I added this, you can say that you can add scale. You can add rules for your scaling. And there are multiple ways to do it. You can scale based on number of requests, how many people are calling your application, and you can scale your application based on that. You can scale based on Azure queue. There's a queue. Let's say if there are 100 messages on the queue, you can scale and create a second instance of my application that is going to process the queue faster than with a single instance. That's how they scale. And you can define how many copies you can have maximum. I think I set maximum to 10, but you can put a number that you want. And that's how Container Apps, is different from that. You just go from Azure. You can also, from here, let me create one, sure. There is integration, by the way, with Visual Studio Code and Visual Studio as well. But from the Azure portal, if I get my subscription, sorry, sure. I guess Azure. I set my region on Azure, I set the name and the resource group on Azure and subscription. And I need to use a container environment, okay? Normally, you can create a new one here. I have done that already. So before you deploy container apps, you have to create this environment where you can deploy multiple container apps. You call container apps environment. But once you create this environment like I have, setting, if you want to set like a network, and also the monitoring the logs, you can use a virtual network or not, and you can use monitoring or not. I have created one of those before. If I have the environment, the only thing I have to do is like run the application. I could get from a quick start, just like a demo sample, just to test, or I could get from like a container registry. Say Azure Container Registry, I probably have Container Registry here with some container image that I have done before. I think AKS Blazor. Not sure if the version of the container I have. And then I can set how much memory CPU I need for mine. I can say half a CPU and 1 gig of memory. Let's see if this one works. I don't need ingress. Okay. I'm not going to set for this one, but just for you to test. Yeah, I could set access for externally or not. I just want to quickly show one deployment using a container hash that I created before. Could be your application that you build and you save inside. In my case, I use Azure Container Registry that I'm going to show that. Let me wait for this to be created. Should not take that long. And I can show where this image came from. There you go. It's already created now. I go to the resource. I don't have ingress because I disable. That's a good way that we can show how to do that later. You can, after the creation, you can enable traffic if you want. I can allow all the HTTP traffic and insecure connection because of HTTP. And there you go. I think that's port 80. That's another way you can use the portal to enable that ingress. When you do this, they're going to give the URL where you can access publicly. And you can do both. You can have these externally accessible or just inside like a private network. Take some time, I think, for the container to start. This .NET application, yes. Yeah, I'm not sure if port A is enabled. We can try differently. Let me see. Let's do on the fly here. I know that we are a little bit more than 1 hour. That's fine. We want to show more than we can here. Let me update the ingress. Go. Yeah, not sure if I'm... Anyway, but like I was showing on this one here, is running there as well on container apps. And AKS is the same, but AKS, I create one cluster here to show you. Everything that you run there is called workloads. Okay? Your application is going to run on these pods. That's your application running. Like you can see multiple applications running here. And our cluster, like I said, is a group of machines, a group of node pools At the moment, I have a single node pool. That's a Linux node pool. And I have one single node. That's my machine. And once you go on workloads, you're going to see what's running on that class. And to get access to this class from the command line, you can use the command line to see the nodes. It's called, sorry, kubectl get nodes. That's the class that you just showed there. We have an agent pool, and you also what you call virtual node pool to run Azure Container Instance. This second machine here is just like a fake machine that will be able to run serverless Azure Container Instance workloads. But then kubectl is the command line for Kubernetes. It's a nice way to see everything that's running. You go kubectl get all dash capital A to see all the namespace. Because Kubernetes, they organize your applications based on namespace. It's kind of a category, like a group. It's called namespace. And then when you search, you get all dash capital A, you see everything that's running on the cluster. Then could be pods, could be service, could be deployments, all the Kubernetes specs you can see here. A simple way to go is not look everything, just look for the pods for all namespace. And as you can see, I have kube system and I have gatekeeper system. If I want to run something here, I think I have something running that I can show. kubectl. Let me show that. On this directory, ACI demo, I have these a couple of virtual node deployments. If I want to run on Azure Container Instance, like I was showing, serverless from Kubernetes. Let me try to run that one. I have here open. This one first. And what I did, I run this Kubernetes YAML file. When I run that command, Kubernetes apply, kubectl apply -f, this file, is I'm sending for the Kubernetes API, remember the API server, I'm sending this deployment YAML file, asking them to run this container image, ACI hello world, and I'm telling them, look, don't run that inside Kubernetes. I want to run this on virtual kubelet, that's Azure Container Instance. The same way that I was running from Docker, I can do from Kubernetes. And then if I go on my cluster, let's see if it's in there. It's not running. Let's go on the workloads. It's a ACI hello one. Yeah, I don't think I set the connection here, sorry. Sorry, I have to enable properly. I have to give access to my ACI from here, but what they're going to do, they created the ACI deployment here, and they're going to run, not here, they're going to run on Azure Container Instance. But that deployment came from my command line when I run the command. That's how Kubernetes works, that from the command line, you run your deployment from here. And then there's a bunch of things that you can see. Let's get one, kubectl, describe pods. Let's get. I think that one. It will be cheap. I could run this command, kubectl describe pod, and describe the name of the pod in namespace. and they give everything about this pod, all the information about this pod. All the replicas, all the arguments, and what is running, all the annotation labels. And also one thing that's very useful, the events. At the end, there's no events for this one. But yeah, they give all the information, IP number. That's the internal IP number of the cluster. In this case, is Azure Network IP number here as well. That's likely, but that's a very, very high level just for you to understand how to operate. Then let me go back to my slides. If you want to discuss based on just information, that's how we sell container apps. Is like a serverless container microservice or application for modern apps, where we use things like project from Cloud Native Complete Foundation CNCF, like DEPA, CADA, and Envoy to run this, and Kubernetes itself. And you can use any language. You just you need a container image. You can use DEPA for microservice. You can use CADA for scaling. And you can have all this life cycle because container apps is not just one instance. They can get multiple versions of your application running in parallel. It's very, sophisticated. That's what we call container visions. And it also can respond based on event-driven, like using CADA, we can respond on when someone adds something in a message queue or someone adds something inside the database. It could be running things responding to events, like event-driven, like serverless as well. You can run on that. And also all the portability, because using open source projects, you can just move your application to Azure Kubernetes Service or any other Kubernetes service in the cloud or even on-premise. Okay, that's something that was the latest announcements. I think this slide is not really the latest, but we have networking, managed identity logs. You can have your domain, certificates, probes, have integration with Visual Studio Code, Visual Studio, full Visual Studio. And that's it. That's things I was showing on the portal. Ingress controller, domains, app identity, secrets, everything there. Similar to what like platform as a service. And you use container apps for that I can use for microservice because it'd be easy for those microservices to talk using DEPA. And DEPA allows that safe communication between those microservices using TOS, multiple certificates using multiple communication between those microservices and TLS. And they manage DEPA can manage all the certificates and all that safe communication between those microservices. And you don't have to care about these. And trust me, many years ago, we used to have to do ourselves. Now it's all done by, by DEPA, by the service itself. You can use for public APIs, having what they call traffic split. You can have multiple versions running, called blue-green deployment or the canary deployment. Canary deployment is very useful when you have one version, you want to deploy the new version, but you don't want to send all the traffic to the new version. You want to make sure that's working first. You send like 20% of the traffic to the new version. And when everything is going well, you can start sending all the traffic to version 2, and then you stop version 1. That's a nice way to do, traffic splitting and deployments as well. Or you can have just like a blue-green deployment where you deploy version 2, you send all the new traffic to the version 2. Once version 2, there is no traffic, nobody's calling version 1 anymore, they remove version 1. It's a safe way to do deployment. It's called blue-green deployment. And Container Apps works out of the box to doing that. That's a big advantage, by the way. You can do web apps, event-driven, like I was saying, or background application. Background application is something that you're going to run, finish running, you're going to stop, and then you don't pay. Those are based, the container apps and those projects I was talking about, the CADA, and I think it's good to understand a little bit. Have a look on CADA.sh. You can see all type of scalars that you can use on Azure Container Apps based on database, on a queue, on memory, on any kind of a way that you can find a variable on CADA.sh to scale, you can use on Container Apps. And DEPA, also DEPA.io, is another CNCF project that's used by Container Apps that allows all these kind of things. One that I like a lot is the service invocation. You can talk between the servers using, like I said, MTOS to have a safe communication, or using logs and telemetry. But if you go back for the main slide, you can see I can use pub sub, secret management, state management, binding as well. Means that pub sub is very nice. I don't want to write the code that talk with like Kafka or service bars, or I just call I just ask DEPA to say DEPA is like an assistant, a library that you can say, can you send that to another service? Can you record that in a pub sub storage, or can you give me that secret, even if the secret is in different products here? You don't have to know all these products. That's a nice way to do it. Why need that? Because maybe locally you're going to be using, let's say here, look at this. You may be locally using Docker to play with these components that you're using, like Kafka. But in production, you're just going to change the DEPA configuration, they point to the Kafka running on the cloud. Means that without any code change, it can change the product that you're using. You could be using Red's cache locally, then set in production to use a different product. Or you could have multiple projects where each one of them you'll be using different technologies, but using DEPA to talk with all of them. Then your code will be exactly the same. That's the magic of DEPA. I recommend you to have a look on DEPA as well, and on Container Apps. And yeah, I think we could be talking for hours, but we don't have this time. And then I'm happy to answer the questions and stop here. Maybe we can do another one another day. Anyone want to open the microphone and ask the question, or I can look at the questions and let me have a look. I'll be... Yeah, you can, like public APIs, you can, when you deploy something, you could not expose to the internet. A lot of companies, when they deploy, a workload, like I was showing with the Container Apps ones. I go back to Container Apps. Container Apps is one that the one that I deploy, and the web one. See, that one, there is like a URL, there's a domain we provide. That's another service we do. We give you a domain if you don't have one, but you can have your custom domain, like your domain that you acquire with your name, your company name. But if you don't, we can provide that, Microsoft domain for you. Like go Azure Container Apps IO, with those subdomains for your application. That's how that works. But if you don't want to expose, you don't have to. You can completely block these to be disabled here, and you won't allow traffic for some IPs or even for your private network. And then that's the way that you can set. You can limit also to for your container environment, not for anyone else. Means that if you're going to deploy the backend application, you're only going to expose to the container environment, only the front end that you're going to expose publicly. That's how normally you accept. I hope this makes sense. Yeah, because when you deploy, even inside the same container environment, when you deploy the backends, you don't want to expose the backend to the public, like the API, and then if some people develop like microservice that's completely isolated from the front end. The front end is not calling that directly. You normally have like an API that call these microservices, and those backend microservices, they could be complete isolated if you want. And also for enterprise companies, they don't want to expose the internal applications to the internet, and they use like custom domains. They even using private DNS to only to be available inside the company. And that's one thing. Another thing that's very nice on container apps now is TCP ports. Means that you can run like even Red's cache here. If you want to play with Red's cache in your application, you can run your Red's cache because you're going to use TCP ports. Hope this makes sense. It's more advanced, but people asking for the forms. Someone asked about API management. Yeah, API management is a product that I used to talk a lot, and is a way to consolidate all your APIs in one place and have a single endpoint. And then you call API management, and the call API management is going to call your backend API. It's kind of a middleware where you have someone in the middle. But the nice of API management is it can do a lot of things on top of the API. It could do data transformation, it could do authentication, it could do all the authorization using tokens and things. So a lot of things it can do inside a product called Azure API Management. I recommend also to have a look. I really like. It's another subject to talk here. If you wanna talk about API management, I'm happy to do one day. I used to be Microsoft MVP for API management a few years ago, and I know a lot about the product as well. Any question? Okay, someone new on Kubernetes service. In what scenario of type of deployment we need to use Kubernetes service? Good question. Look, Kubernetes if you use container apps, is a way to deploy your application as a container, and you only pay for the for the amount of time that's running, like a serverless thing. And you can deploy anything on Azure Container Apps. That's also Kubernetes, okay? But you don't have to manage all these things. The companies today, they go more than that. They want to also do more complex things where they have to integrate with the network of the company, and then they have to move from container instance or container apps to a full Kubernetes deployment. It's called Azure Kubernetes Service, where the sysadmins, the DevOps people here will be able to manage more things than they have available on container instance and Azure Container Apps. Then I have three main products: container instance, Azure Container Apps, and Azure Kubernetes Service. Container is for single deployments, just run and stop, or background application. Container apps also for the same things, but we can respond to events, respond to queues. We can run pretty much anything that you have a container image ready to run. And you can have also TCP ports and everything. And because Azure Container Apps run inside the environment, you can have the whole application, all the microservice, all the components of your application running in there. Okay, and the nice thing of all these three solutions is why you choose that is the way that you scale your application. If you're building something that you need to be scalable, what's scalable? When you create an application like an API or web application, let's say Google, say Bing, you have Bing now. All the search engines like sites that we call, a lot, or your news website, your, retail website, they have to be available. Your travel website, they have to be available all the time. Means that they have millions of people calling the same website, but it's not the same instance. It's not the same application running like running your machine. Could be running thousands of instances, and everyone that's calling those instances are running in different place. Normally they access, a similar database, and that's the way that we scale application. And these days, most of the startups and things, they building things that they need to be scalable. If you're building like a mobile app and you write an API for your mobile app, if that's become viral tomorrow, you need to scale. You don't have to do that on day one, but on the day that your application needs to scale to respond to like 1 million concurrent users at the same time, you're going to need to scale out. Because, like I said, there's a maximum amount of CPU and memory that you can buy. You cannot run everything in a single instance. What's the limitations? Limitations are CPU, memory, networking, internet connection. I don't have a machine that with 5,000 CPUs and 100,000 gig of memory with unlimited internet and network to support 2 million concurrent users. I need to scale this to multiple machines. And cloud native and containers and all these container apps and Kubernetes and container instances are, products that can help you to do that, to scale out. When you say out, is outside one machine. You can have running multiple machines. When you say scale up, is with more memory and CPU on the same machine. It's like you have your laptop there, your notebook laptop's not good enough anymore. What you do, you buy a better one with more CPU and more memory. But there's a limit. Then, if you want to scale out, containers are your friend. And if you work for someone, you're going to find out that they have to scale out. And you need something that can run in milliseconds, not like 1 minute to run, because the 500,000 customers that you want to access on this millisecond, they're not going to wait 1 minute for your application to be running. What are you going to do? You're going to say, application not available, please come back in 1 minute. No, we have to quickly scale. But imagine that overnight, there is just like 1,000 customers accessing your retail website. What are you going to do? You want to pay for 2 million or you want to pay for 1,000? That's why you scale up, you create more machines, but when they're not using, they're going to scale down and you only pay for the consumption. That's the magic. Otherwise, the cost would be, unbelievable high and nobody will be able to pay for that. And if you want to work for startup or for enterprise, you have to understand that. Because you're not going to build something and ask them, no, I need 100 VMs running all the time, waiting for the traffic to come because my application takes 5 minutes to run. And there's no way for the customer to wait 5 minutes to scale up and down. That's the main reason to use, cloud native applications are that. Hope makes sense. Just wait. AKS or Azure Service Fabric, when to use. Service Fabric, Microsoft use internally. We're not recommending for you to use Service Fabric anymore. AKS for sure, or Azure Container Apps. Service Fabric used to be on-premise, is open source as well, but we don't recommend for new products, just to maintain what's existing are. And, was something that you see a lot of things on Azure running on top of Service Fabric, but most of the new service on Azure runs on top of Azure Kubernetes Service. Then, it should be doing the same as well. What more? Let me go back here. Okay, get your participation certificate. In Docker, it probably manifests on, is that Docker Compose or Docker? I'm not sure exactly what you have to, yeah. The main reason to be, a compose file like this one, that's the compose file I was using to deploy. So yeah, you can use that compose file to deploy a mode. Someone was asking about Docker Compose to run web and DB. That's a good example you can run using Azure Container Instance, by the way, using web and DB. You can run locally or you can run these on Azure Container Instance. Could be YAML file, because YAML file is a space here. Look, it's not a tab. Make sure that you use Visual Studio Code, because they're going to fix the space for you. If you do a tab, they convert in the tab in space. But YAML file need that indentation here. If that's wrong, probably maybe you'll be failing. Same for YAML files. Source. Yeah, Docker Compose could be the indentation of the file, or could be the indentation here, or could be your command. Make sure that you point to the right file when you run. I say let's run this one here. You have to Docker context use ACI context, and then I think I can run that. There you go. I use Docker Compose this file. That's Compose file that I have open here. They're going to create a web application and a DB file in a database, a SQL Server, SQL Edge. It's a way to work with SQL Server on Azure Container Instance. It's not going to be running locally, because I'm asking to create on Azure. And that's a nice one. I think I haven't done that before. I think pick this one. And then containers. There you go, web and DB. And then it's going to take some time to start. But that's the way that you can run from Docker Desktop using Docker Compose multiple, Docker Compose multiple containers using Docker Compose. Hope that helps. Yeah, it's going to take some time to create. There we go. Crash. Say that's running. Yeah, not sure if I exposed that one. Anyway, I had to test internally because I haven't exposed, but you could connect that and see. We'll see the logs here. That's it. I think I'm going to stop sharing. Otherwise, it's going to be too long here. Okay, people getting certificate. Turag, are you there? Thanks for the invite. I really enjoy showing that. It's a lot of things, containers. Don't get overwhelmed, I think, by the amount of information here. Try to follow if you can watch again and try to understand. If you watch this in a month time after reading something, go on Azure Tar, subscribe the channel, and try to watch some Docker and I have some videos there, and then come back, watch this again, then we probably make more sense. If you are a beginner, like I saw many people here. But thanks a lot, appreciate it.
Thank you, George. Thank you all for joining. I have shared the certificate link and a few resources regarding the Azure container itself. It will let you start again, like if you don't have any idea, and so that it'll be easier for you. And thank you again for George for the session. It was really, really resourceful, and I hope everyone here was able to learn, and it will be helping them to get started on containers and learn further. Okay. Thank you, George, and I think we are on time. It took a little bit time, but I think it was worth the time. And thank you.
Thanks so much. I appreciate it. Keep in touch, everyone.